how is data represented in just regular text? There are many ways you could structure data as text, but when it comes to practicalities and actually how people really do it in practice, there are only a couple of different ways that people do it in most cases. There are comma-separated values files, which we'll see the details of in a second. There are JavaScript object notation files. There are XML files, also known as eXtensible Markup Language. These are by far the most common formats that people store data in. And the goal of all three of them is to make the data easily understandable by a human, but also easily understandable and parsable by a computer program, machine readable. So it's supposed to serve both purposes. You should be able to open up a file in one of these formats and understand what the data is. Maybe not easily, but you should be able to do it without too much difficulty. And the computer should be able to go in and find all the lines of text in the file and be able to easily find different pieces of data in each line of that file. All right, so what do we mean by plain text? When we say plain text, we mean particularly very specific data format. And you might just say, oh yeah, it's text. Well, that doesn't really do it justice. That doesn't explain, what we mean when we say text on a computer. And when we say text on a computer, let's bear in mind that all data on a computer is stored as numbers. Every single thing on your computer, pictures, videos, everything else is all numeric data that you are storing in your computer's processor, in your computer's memory, in your computer's RAM, hard drive, video screen, monitor, and so on. It's all the same kind, which is numeric data. Now, so what do we mean when we say text data? Well, text data, like all data, is numeric behind the scenes. So when you type a character like an A or a B or a C on your keyboard, you're going to be storing numeric data in the computer's hard drive, on the computer's RAM, in the computer's processor. And anywhere that data goes, it'll be considered numbers. So when we're talking about text data, we're talking about data that is numeric codes that correspond to characters, letters on your keyboard, or letters that you can write in other languages in the world. And there are specific encoding systems for how to do a translation from a letter that you might type as a human to the number that the computer might understand internally. So every time you type in A, according to one of these encoding schemes, there's a specific number that corresponds to lowercase a, a specific number that corresponds to lowercase b, and so on. So it's not just up to the computer and the maker of the computer. There are international standards of these things, so that every computer that's made by all the main manufacturers of computers and all the main operating system companies like Apple and Microsoft and Google, they all do it the same way, right? So these are the ASCII and Unicode standards. These are the ones that are universal at this point. So there's no arbitrariness about what number an A is, what number B is. It's all fixed according to international standards. ASCII is an older scheme that was Anglo-centric. It only supported alphabetic characters in English, plus some other punctuation marks and stuff like that. But it was all Anglo-centric, meaning no other languages except English were encoded. There were no numbers for French characters with an accent mark or Mandarin characters. There was nothing like that. So, so that was an older version of what is now the standard, which we now have as Unicode. And Unicode is really an extension of ASCII. They took all the same coding numbers for ASCII. All the, A is a 90, B is a 91, C is a 92, and so on. And just upgraded that system so that, yes, those numbers stayed the same for English, but we also had room for all the other languages of the world as well. So that's the more modern version of a standard, which is called Unicode. So A is a 97, B is a 98, C is a 99, and so on. And for every single language that is known in humanity, Unicode has some kind of a code for each character in that language. At least there's languages that are written, because some are not. How do we create plain text data? You use a plain text editor. It's not a mystery. There are programs that do this. If you want to write text, you pop open a program that allows you to write text, right? You might pop open, if you're writing an email, you might write text in your email program. If you're writing a report for a class, you might pop open Google Docs or Microsoft Word, right? So there are different programs that allow you to write text. Not all of those are plain text editors in the sense that we're talking about. Windows Notepad, Apple's Text Edit, and I'll throw in here Microsoft Word, Google Docs, Apple Pages, these are not good plain text editors. Now, they might allow you to put in characters like A, B, C, and all your normal international language characters, but they actually allow you to put in more than that. So in a Google Doc or in a Microsoft Word document, you can put in pictures. You can put in, I don't know what, smiley faces. You can put in, which actually might be okay, but you can put in all kinds of stuff that isn't just text data into those programs. They're not just purely text editors. They allow all kinds of other things like formatting. You can make things bold and not bold. That's not text information, right? When I make a document that says that this text is yellow, that's not written in text here. That's some additional metadata that is being stored in that file. That's not just the text that is the visible stuff, but there's some other information being stored in this file now that says that that part's yellow. That is not simple, pure, plain text anymore. So none of these programs that you're used to using, unless you're a programmer, which some of you are at this point, none of them are good for plain text editing. None of them will limit you to only plain text characters. The only programs that will do that, that will ensure that whatever you type into your text is actually really a key or a letter that has a corresponding Unicode value, the only ones that'll do that will be dedicated text editors, which are almost always code editors. So that's what we mean when we say creating a plain text file. We're saying using a program, a text editor that only lets you put in plain text and nothing else into those files. Because putting in other data will corrupt the files if you are allowed to do that. So how do you save a file with just plain text in it? Well, you go file save, of course. But you always need to include a file extension. This helps the computer and the human looking at it understand what kind of data is in the file. So if we go back to the formats that are common formats that I mentioned, CSV, JSON, XML, these are the common formats that we'll take a little bit of a look at. Your files should always end in .csv, usually lowercase, or .json, lowercase, or .xml, lowercase. So that helps you and the computer understand which kind of file is that you're making. So when you double click on it, if it's a CSV, some program that knows how to read CSVs will pop open. If you double click on it and it's a .xml, some program that knows how to read XML files will pop open automatically, right? So it helps your computer know what to do when a user takes an action on that file. You can mislead your computer. I can name any file like a CSV file. I can name it .zip. My computer will think it's a zip file. When I double click on it, it'll try and unzip that file, which will fail miserably, but it will try to do that. So the dot extension doesn't prove that the file is of the type that you're saying it is. Of course, you can trick your computer if you want to, but it helps, assuming you're using those extensions correctly for the right formatted files, it will help your computer know what to do when you click on it. If you just have a file that doesn't have any particular structure, but it is plain text, doesn't have any additional images, videos, formatting, nothing like that, a default extension would be a .txt for text. So if you're not using CSV formatted text, if you're not using JSON formatted text, you're not using XML formatted text, or no other specific formatting of your text, .txt is your fallback option. So use the extension that matches your way of writing the text. So I'm sure you're dying to know, what does a CSV look like? What does a JSON look like? What does an XML look like? Well, we're going to get to that in just a second. When you double click on the plain text file, you'll probably get the wrong program. If you're on a Mac like me and you double click on a .csv file, anyone know what program opens? Excel, if you have Excel, or Apple Numbers, which is the equivalent made by Apple if you have Apple Numbers, yes. But you're going to get a spreadsheet program popped open. And maybe that's what you want, and probably until this class that was what you wanted. But sadly, you're not going to be wanting that anymore. You might still be wanting that sometimes, but often you want to open up a different program like a text editor to edit that text directly. The spreadsheet will give it to you in a graphical way where you don't see the commas. You see, just a grid of data cells, and there are no actual commas there. You might want to edit those commas, edit the actual text that's in that text file. And the spreadsheet won't let you do that. All right, so instead of double clicking, I hope, as general people learning how to use computers in a computer science department in a university that's supposed to have a decent quality, that you're going to know how to open up a file in some other program that you actually wanted to open up into, not leave it up to the whim of your operating system to decide which program to pop open your file in. So how do you do that? Well, go to the program you want to use, like Visual Studio Code, like I don't know what else you're going to use, and go File, Open to open the file. Right? So it's not as convenient. You don't just double click and get the program you want. You have to go to the program first, and then from the program, pick the file, go in reverse. There is a way to do it. I'm not sure if I mentioned that here. Yes, there is a way to do it that you can change your operating system's settings so that CSV files aren't associated with Excel anymore, or Apple numbers, or whatever other spreadsheet program you use. But you can reassociate CSV files to be for Visual Studio Code, or .json files to pop open in Visual Studio Code, so that you can double click it and get the program that you want actually open. So there is a way to do that. You can look it up, search how to do that, you'll find it. But barring that, just go to the program, go File, Open, and you will not have a problem. One more note, and this is me being annoying because it gets into technical things on your computer, and everyone has different computers, so they're all going to be a little bit different. But generally speaking, your operating system, whether you're on Windows or Mac, but not on Linux, when you're on Windows and Mac, your file extensions are hidden by default. So if you have a .csv file on Mac, it won't show up with the .csv extension. It'll show up with the name of the file, like my favorite data. It should be called myfavoritedata.csv if you named it that, but your operating system will show it to you in your Finder or in your Windows File Explorer. Will show it to you without the file extension for some reason. And as a person who needs to know exactly what files are called, because you're going to write programs that will break if the file name isn't exactly right, you need to know exactly what your file is being called, and you need to see the file extension in order to know that. You're going to want to see those file extensions. So it is urgent, meaning you will not successfully open up files and write programs that deal with files unless you change that setting on your operating system. So this is something that you actually do have to change to become a more proficient user of data. You want to see the file extensions always. So I'm just linking you to a search here, but look up how to do that for your operating system, whatever operating system you're on. Look up how to change the settings to show file extensions by default. It's easy enough to do. There are lots of tutorials on how to do that. But that's a basic thing that you probably should have been taught in Intro to Programming class, but probably weren't. Just generally do that so that you'll always know exactly what every file is called and there's nothing hidden from you. All right, so a format that I actually didn't list because it's not that common, but something I think that's interesting is the fixed width format. We're actually going to see an example of this shortly, but back in the days when paper ruled, meaning back in the days when offices and homes were filled with paper documents, which is less and less the case every year, you often had to format your text in a way that printed nicely, fit a printed page horizontally. And so the fixed width format of text was born. It aligns nicely on a printed page, so the columns are all visibly columns. Right, so you want the data to be lined up nicely so when it prints, your eye can kind of follow a column up and down on the page. So often you have fixed width when you're dealing with data that comes from the world of print. So just an example of what I mean here, that each column takes up the same amount of space. Let's see an example here. Okay, so March, and 1, 2, 3, 4, 5 spaces altogether for that column. That doesn't matter how big the number is. Any spaces that aren't needed for this column are just filled up with space, right? So the number 11 takes up as much space as the number 4, right? It's a fixed width. There's an equal amount of space dedicated to these numbers, regardless of how much space is actually needed by those numbers. 3 and 4 being 1 character long and negative 11 being 3 characters long. At least they're all given the same amount of space and just padded with spaces if there's too much. If they don't need the space that's available. It's filled with spaces. So this is a fixed width layout. If you printed this, it would look really nice. All the columns would be lined up nicely. Much better than a CSV, which wouldn't have these extra spaces to line things up nicely. So you'll come across fixed width text formatting in data files. And this is actually a bit problematic if you're a programmer who's trying to then read a file with a fixed width format where different numbers of spaces are between different parts of the data, right? There's like 4 spaces here and 2 spaces here, right? So it's not consistent. It's not like you can say that every bit of data is separated by the same amount of spaces. You're going to have to be a decently proficient coder to write code that is able to grab the data from any one line and grab each bit of data, ignoring the spaces when you actually can't say that there's always going to be a consistent number of spaces. that's a bit more work than it really should be for a programmer. Those of you who know Python or Java, which are probably the languages everyone here knows, you can do a split function. You can take a line of text and split by comma if it's a comma-separated values file. You can just say, go look for all the commas and chop up the data according to where the commas are. Well, here you can't do that. You can't just say, go find all the commas or go find all the spaces. You have to say, go find all the spaces of variable numbers of spaces and go slice according to that. And that takes it's not so hard, but it takes an extra level of effort that we lazy programmers usually don't want to do. So this is, it's not really suitable. It's not intended to be machine readable in an easy way. That's not the intention. The intention here is to print nicely on a screen or on a piece of paper. Let me pull up an example, NASA's record of land and ocean surface temperatures. Let me just pull it up. So NASA has a special unit dedicated to tracking the Earth's temperature. When you hear about global warming, well, here's the data. This is, of course, there's much more than this, but this is historical records of global surface temperatures, and they average them out for different months of each year. So starting in 1880, where they started apparently this unit in NASA, they've been measuring the average temperatures for each month of the years from then. Now, this isn't the actual temperature. If you actually read the description of this data set, they'll explain to you that these are indices. So there's an index that's being used here. This is the variation from that standard value that they're calling the index. So they've decided, and I'll just point it out to you here, base period 1951 to 1980. They've taken the averages from 1951 to 1980, and they're saying how different was 1880 from the average of that period. How different was this 1881 from the average January of this period, right? So they're giving you the relative change from that base period. So these are not actually the temperatures themselves, but the difference from what they're considering the standard temperatures, which are the averages of 1951 to 1980. Anyway, so that's the data set here. It's from NASA. You can go to this site, click that link, and peruse it yourselves. But, it's interesting stuff. You'll see that things are getting warmer, but you'll also see that the data is in fixed width column-based format, which is not very useful to us as data people. So yes, we can write a code that would parse this, that would break this up into its little data parts, but it would take a little extra work that we're not happy to do, but we will be doing, yourselves will be doing very shortly. All right. So that might be shocking to you. NASA, government, I don't know why you'd be shocked, but government publishing data in an outdated format should not be shocking to you. There are probably still people who are using this, who this is useful for. So they're continuing to publish it in this fashion. All right, so it's print friendly, human friendly, print friendly, but machine unfriendly. All right, so back to comma separated values. These are values separated by commas. Line breaks separate the rows. So you have here 3 different works of nonsense literature. I'm a big fan of nonsense literature. And here's the Jabberwocky by Lewis Carroll, who also wrote, of course, everyone's favorite book, which is Alice in Wonderland, the author. He wrote a nonsense poem, which I think it was originally part of Alice or Through the Looking Glass. Anyway, this is a piece of literature by him. Then there's Edward Lear's The Jumblies, one of my personal favorites, and Elizabeth Bishop's The Man Moth. So these are 3 well-regarded pieces of a genre of literature called nonsense literature, where it's complete nonsense, but it has a meaning even though it's nonsense. It's actually an interesting art. And so I'm storing that as comma-separated values. You'll notice that each line is a single record, a single piece of literature. So the first piece, the second piece, the third piece, right? You don't put 2 pieces on one line. That would be just poorly formatted use. A poor use of CSV. So the idea is to keep a single kind of self-consistent record on a single line and have line breaks separating those records. Each data point, each value that is of unique interest to us is separated by commas from the other values that are of unique interest to us. So all the values are separated by commas, which is why it's called comma-separated values. So that's the idea of a CSV. You've all seen this before, I think, but just to kind of enforce it into your minds in a new context. So we also optionally have heading line. You can at the beginning of your data indicate the names of the headings. So last name is in the first position, first name is in the second position, title of the work is in the third position, and year is in the fourth position. So that's not uncommon. Helps people understand what the data is about and helps your computer program understand what the data is about by reading this first line first. Notice that if we go back to NASA's stuff, which I'm not sure if I still have it open, but let's pop it open again. They have headings. Well, first of all, they have all these lines of text above here that aren't the data that you're interested in. They do have column headings here. So that's a part of this kind of format as well. But notice that they have repetition of those column headings here and another repetition of those column headings here. If you're writing a program, you're going to have to skip these lines that are useless to you. You just want the data points. You don't want all these spaces and all this extra stuff going on here. Does anyone know why they would have repeated the headings like this?
Multiple pages.
Yeah, for printed pages. So this is page 1 on your printer. That's page 2 on your printer, and you're not going to see the headings unless you repeat them, right? So it's a print-friendly format. Very good. All right, so let's go back. So that's CSV. CSVs are considered fixed schema. Structured data, structure and schema are really interchangeable here, but the structure is consistent. What I mean by that is every line has the last name in the first position, has the first name in the second position, has the third thing being the title and the fourth thing being the year. There's no variation from that schema or from that order of structure. That's consistent, that's defined by the heading line, and anything different in any line would be a mistake, an error. Right? So this is a very strict, regimented format. All right, so we just discussed what's here. Inconsistently ordered data would be unusable by a machine and probably by a person as well. So imagine that the data was like this. Yes, it's comma separated, but there's last name, first name, title, year in the one work, but year, first name, last name, title in the second, and title, year, last name, first name in the third, right? They're all different orders of the values. This would be very difficult for you to write a program that said what the titles were for every work. How would you even write a program that would figure out which ones were the titles? It would be pretty much impossible unless you had a reference document of all titles that you could compare them to. So this would, this is not human and not machine readable in any easy sense. So don't do that, right? When you have CSVs, keep the order of each line in the order indicated by the rules, which are often indicated in the heading line. Questions, comments? Okay, carrying on. A variation of CSV is TSV, tab separated values, just to bring it up since you might come across it. In this case, these are tab characters, a tab being a single character in terms of code. These are not space characters, which they look like multiple spaces, but it's really just a single character in computer programming terms that is separating these fields. So a tab is a single character separating the fields. So instead of comma, sometimes it's more convenient to separate by tabs. When would that be more useful? I'm not sure it ever really is. But you have, in some cases, you have actually commas in the data. Let's say there was a title of a work with a comma in it, like Jabberwocky, comma, haha. Let's say that was the title of this work, right? Then the comma might be mistaken for a separator. Well, how do you get around that? Well, you can use TSV instead. So commas are not treated as separators, but tabs are. Another way of getting around that is to put the title in quotes, and CSVs do have that as a consistent standard. If you have values that have a comma in them that you don't want misinterpreted as a separator, put the whole thing in quotes. And any program that's well written that reads CSV files would know that that's a singular value, not to break it up according to the comma inside those quotes. All right, so while you can use commas or tabs as the separators, you can also use colons, semicolons, pipes, these vertical line keys that you have on your keyboard. These are commonly used as well, again, for reasons where the comma or the tab are needed in the values and people wanted to use some other character for that purpose. If you have ever gone and fiddled on your command line on your computers with your path variable, has anyone ever done that? Fiddling with the path on Windows is one of the things you do on Windows. The path variable includes a list of files and directories on your computer that are used frequently by the operating system. And the separator to separate the values in that list of directories is a colon, I believe. If you're using a Mac, you have a path variable that you sometimes fiddle with as well. And the separator in that list of directories is a semicolon. I'm sorry, it's the other way around. Windows is semicolon, Mac is colon. You don't know what I'm talking about. Let me pop open terminal. If I do echo path, this is a list of directories that are commonly accessed by my operating system that are just conveniently listed here. And this is one of the directories, colon. That's the other directory, colon, right? So they're using a colon separated format for whatever reason, I don't know. That's what they've decided to do. Windows, you'll have the same thing, but just with a semicolon. They like to be different, right? Windows and Mac. All right, let's carry on. JavaScript object notation, another format. Now this is slightly more flexible. You have more flexibility in the schema. It's a competitor to CSV. So CSV has been around ages. It's been around decades as a standard format that data is stored in. And it's well tried and well tested, and many programs can open up files in CSV format and import that data into their own programs like spreadsheets. So JSON is a newer format in the sense that it hasn't been around for 4 to 5 decades like CSV. It's been around maybe, I'm going to guess, 1 decade. So it's it's a new kid on the block in the file format world, in the text format world, but it is a powerful and actually at this point very widely adopted format. Not as widely adopted as CSV, but very widely adopted, especially in technology companies and the tech industry. So it's useful for storing structured data like CSV, but also useful for storing slightly less structured data where the schema is not so strict and rigid. For example, here are our works of nonsense literature, one work of nonsense literature in JavaScript object notation form. So rather than CSV, where you have one line with a record's information on it, a piece of literature is full set of information on one line, you can have line breaks here if you wanted to. So the line breaks are not indicators of a separation of one record from another. Here you've got labels for each piece. Last name is Carol, first name is Lewis, title is that, and year is that. If you had a second record, it would look just like this, but with Carol replaced by Lear, Lewis replaced by Edward, if we're talking about Edward Lear, and instead of title, the Jumblies instead of Jabberwocky, instead of 1871, 1940, whatever it is for the Jumblies, right? So you'd have the same schema, probably, the same labels for each value, but different actual values in there. This might look to you like a Python dictionary, but this is JavaScript notation, which is almost identical to Python notation for a dictionary. This is an object in JavaScript. So that's that. That's the way you'd write that kind of a format. And line breaks, tabs, spaces are not meaningful in JSON, so you can add as much spacing to make it easier for a human to read as you'd want. And that is one kind of freeing or liberating feature of JSON. Here's what it would look like, on one line. You'd have the whole thing just kind of spread out on one line. You can do that, and you would often do that if you had a lot of these. You'd probably just put it on one line. But if you wanted it to be easier to read, you could split it up onto multiple lines. It's not important. If you had more than one record, you would probably put them in an array. And this is how you'd indicate a JavaScript array. An array is like a list for Python people. So Python, you have list. JavaScript, they call the same concept an array. And this looks just like a Python list, right? So you've got an array or a list, and each one of these dictionaries is one item in that list. And you separate them with commas like you would any list. So this whole dictionary or object in JavaScript is one item in that list, and then comma. The second dictionary is the second, and then the third dictionary is the third, right? So you can have as many as you want in a list. So this is actually code, but it's a way of writing plain text that encapsulates structured and somewhat less structured data, which we'll see in a second, and a standardized format that's easy for a human to read and easy for a computer to read. One of the downsides here is that you have redundant headings, right? Last name, last name, last name, first name, first name, first name. Right? Half of this file is filled with these labels that are pretty much identical, or they are identical, for every record. So there's a lot of space used for redundant information. It's kind of like the headings in the fixed width that were repeated every page, right? It's the same kind of thing. Every document has its own headings, which is a waste of data, really. So that's a downside to this compared to CSV. The square brackets indicate an array, which is like a list, and commas separate it. So we just talked about that. JavaScript object notation can support a hierarchical order of the data, also known as nesting. Let me just show you an example. You can structure this data in a more grouped way, where if there's a record about a piece of nonsense literature, the first name and the last name are about the author, right? So you can bundle those up into their own little object like this, or call it a dictionary if you want, but it's a JavaScript object, and label that author. And here's all the information clustered together about the author. And then this stuff is about the work, so it's kept separate, right? So you could do something like that where you start to group conceptually and bundle together related bits, subsets of a record's information. That would not be possible in CSV, right? So here's where we start to see the differences of JSON and some of its advantages. You have a greater degree of control over the structure. You can actually have substructures. So less structured data. So JSON, another advantage to JSON, despite the fact that it has ability to have substructure, is that it also can have loosely structured or almost unstructured, not quite unstructured because everything has to be labeled, but the labels don't have to be consistent. So that's why I'm calling it loosely structured. Imagine you had 3 people where you had different amounts of data and different parts of data for different people. You could have a name, Bob, for one person and age 10. That's what you have for that one person. But for another person, you might have their last name different from their first name, separated out from their occupation. You don't have last name and first name for that first person or occupation. You don't have age for that second person, right? So these records have totally different sets of information, and that's fine in JavaScript object notation. That's not fine in CSV. You'd have to have columns for last name, column for first name, column for age, column for occupation, column for name. Every possible field you might want in any document, you'd have to have columns in every document for that in CSV. Whereas here, you can just specify what you have, and you don't have to worry about what you don't have in every given record. It is super popular, heavily used. It is not replacing CSV, but certainly giving CSV a little bit of a run for its money in today's usage. CSV is, of course, great when your structure is consistent in every record. Reduces the amount of data you need to keep structured, consistent, fixed schema data. JSON, where you want this flexibility, you want to be able to have substructures, and where you want to be able to maybe have some records that have different data from others. That's where JSON excels. Extensible markup language, and I'm showing this here because you'll hear about it, you'll find data sets in it, but this is now on the way out. This is a last generation text data format. Like CSV and JSON, XML can be used to represent structured data. And like JSON, it can be used to represent slightly loosely structured data, you'll see. Here's the same kind of a document in XML. Again, the 3 nonsense literature works. And you would have, I don't know if you know HTML, but many of you probably do. And this looks like HTML, if you know HTML. It's following a same kind of a syntax of a language of HTML, which is used to make web pages. But this is not HTML, this is XML. You always start every XML document with a declaration of what version you're using, which character encoding you're using. This is one of the Unicode character encodings. Nonsense works has to be surrounding everything, or some labeled what we call tag has to be kind of around everything else. So there always has to be one beginning and ending of the mother or parent tag of everything else. And then for each sub element, you would have a singular element tag around that. This is the beginning and ending of the first work element. And you'd label each piece of data, last name, and here's the beginning of last name, and the slash means the ending of the last name. Beginning of the first name, ending of the first name. Beginning of the title, ending of the title. Beginning of the year, ending of the year, right? So everything in between those is the actual data. So this is even more redundant than JSON, right? Because you need to have 2 times the number of fields, and this has to be repeated for every record. So twice the amount of data of JSON, which is many times already the amount of data of CSV, just for the same information. So very redundant in terms of the same text being repeated in multiple places. It's easy to machine parse this, so you can write programs pretty easily that ignore the things that are in greater than less than signs, but pay attention to the things that are not, in using these as the ways to find the values that come after them. So yes, it's easy to machine read. It's pretty easy for a human to read too. So it validates itself along those lines. But the redundancy is what kills people here. So these days, there's no reason to use this instead of JSON, in my opinion. Some people might find obscure features of XML that are still worthwhile, but I think most people recognize that this is more redundant than we need to have today. So you'll still see data published in this format because there are still many programs that read this format. Before JSON came around, this was the flexible format, and that's just not necessary anymore. You can do like what you can do in JSON, where you nest or give substructure to some parts. So I could say each work has an author. Here's the beginning and ending of the author, and that encapsulates the first name and last name into this thing called author. So you get this kind of conceptual hierarchical structure to the data, where you can qualify different fields as belonging to different subparts of a work. All right, so for less structured data, you could have like what we did with JSON, where you have different records having different fields. So this person has the name and the age, Bob, who's 10. This person has the last name, the first name, and the occupation, right? So you can have different fields, inconsistent schema, and that can be fine in XML as well as in JSON. So for loosely structured data without the fixed schema, this is an option. Although, why use this instead of JSON? I don't know. It is similar to other markup languages. So in that sense, it's familiar to many people. HyperText markup language is the language of the web. This is every web page uses this language, HTML, to publish the content of a web page. So if you've ever published a web page, you've seen HTML, and XML looks familiar to that, so people might like it for that reason. However, the latest version of HTML, which is HTML version 5, is not directly related to XML, whereas the previous versions were following the rules of XML. So they followed exactly the same rules. The latest version of HTML doesn't follow exactly the same rules as XML anymore. So that's just some details there. If you're publishing a podcast, you publish podcast information as usually, there are several sub-varieties of these formats, but RSS, which stands for Real Simple Syndication, is a file format, a text file format where you publish your information about your podcast. And in that information are links to the actual audio files. And you can see an example of a podcast document here. Let me just pull it up. So it'll look a little bit like what we just saw with XML with these tag things. Like here's the beginning of the pub date and the end of the pub date. Here's the link to some site where this is published, and there's the end of the link. You'll have the actual audio files somewhere. I don't see the audio files here. I can't tell where the audio files are, but they would be linked in here somewhere as well. Anyway, so you have these tag-like things. Beginning of a channel, there'd be the ending of a channel somewhere. Beginning of the title, ending of the title. Common way of writing marked up code. Code with annotations. So that's RSS. That's still used widely today for podcasts. That's how you publish your information about what's in your podcast. And if your podcast is picked up by one of the big podcast distributors like Apple, iTunes, and so on, the information in that file, the text information in that file, is why Apple shows you the series of tracks that it does when you're popping open a podcast. All that information about the track names, the audio files, the pictures that go with the tracks is all in that text file in this format. Scalable vector graphics, SVG. This is an image format, which is actually a text-based image format, which you can take a look at. So this is what an SVG file looks like. It starts with the declaration of XML, has a tag called SVG at the beginning and ending. A rectangle starts with the word rect and ends with the word, actually, it ends with a slash. Okay, I take that back. It doesn't end with the word rect, but it does follow the rules of XML, which can allow an ending like this as well. My point being here, just to show you, there's a world of languages like this, like XML, or actually that are versions of XML, that are widely used in the web especially, and other kinds of publishing. So for that reason, it has its charms because it's a familiar world. But again, I think it's more redundant than JSON, really does the same thing as JSON, and I would say that it's going to soon be gone. well, it takes a long time for technologies to die, but 50 years from now, it'll be totally gone and JSON might be alive. All right, that's my prediction. HyperText markup language. You often, although this is not one of our official text file formats, you often will come across data in HTML code, in code of web pages. You might have data that's only available on a web page, and you need to get the data out of the web page. So that's a common need. It's not a general purpose data plain text format because it's really specific to publishing to the web, but nevertheless, you often have to deal with it. So HTML is used to define the structure of content published to web pages. It's not today a direct descendant of this XML language, but it does still have a lot of rules in common. And we often need to deal with it. So it's an important format. This is an example of an HTML page. This would be a web page potentially. Let's say I made a web page about famous works of nonsense literature, and I had 3 works that I wanted to post about on my page. Here's beginning and ending of a section. Here's the beginning and ending of a heading. And here's one work that I'm publishing about. Here's an article, and it begins here, ends there. Here's the name of it. Here's the author, and here's the date it was published, right? So this would be how I might publish a web page that contains information about 3 works of nonsense literature. Notice that the labels are not as clear in HTML. It doesn't say, first name, last name, or it doesn't say name even. It actually just says paragraph here and there. It doesn't say title of a work of art. It says H2. That means a heading, a subheading actually. So the data, the structure of it will not always be super clear. If you're a human looking at this code, or if you're a computer program reading data from a file like this, the file itself doesn't tell you what the names of the fields are. The labels here that are being used are really about how it should show up on the web, not about the conceptual meaning of that bit of text that's within there. For example, there's a line break. Well, that's not part of the data. That's just how it should show up on the web page. So there are all kinds of things here that are not related to just labeling and annotating the data, but are really focused on getting it to look a certain way on the web. So this becomes difficult to automatically write a program that would look at a file like this and figure out what's what. Has challenges. So it's not meant for data sharing like CSV and JSON and XML are, but it is nevertheless commonly used to extract data from HTML. Is very common because there's so much data on the web that's published in no other format except for HTML. So it's primarily used for publishing web content in a visually pleasing manner. That's very different from CSV, JSON, and XML. Does not require a consistent structure. One web page's structure will be wildly different from another web page's structure. There's no consistency at all